We are going to talk about how to simplify the powers of I. And in order to best see what's going to happen, let's take a look at a couple of examples. I to the first power is just equal to I, right? So we don't need to write the exponents of 1. We just normally suppress it and just write the base. I squared is equal to -1, and that's by definition of what I squared is. I to the third power can be thought about as being I squared times I to the first power, but I squared is just -1, so you get -1 times I, which is just -I. And then I to the fourth power can be thought as being I squared times I squared, but I squared is just -1, so you get -1 times -1, which is just 1. So those are the first 4 powers of I, and we're going to find that those are super important, because if I go on and compute I to the 5th power, well, in this case, I don't want to break things up into I squareds. I want to break things up, if I can, into I to the 4th power, because I to the 4th power being a 1 was important because that piece will just kind of go away in the computation. So I to the 5th power can be thought as I to the 4th power times I to the 1st power. But I to the 4th power is just 1, so I really am looking at I to the 1st power, which is just I. So now I'm back to just looking at the I to the 1st power. I to the 6th power can be thought as I to the 4th power times I squared. Again, the I to the 4th power just goes away as a 1 multiplier, so I'm really just looking at the I squared, which is -1. So similarly, I to the 7th power will just break down into thinking about I cubed, which is -I. And then I to the 8th power is another multiple of 4. So I to the 8th power I can think about as being I to the 4th power times I to the 4th power, which is just 1 times 1, which is 1. So if the exponent is a multiple of 4, it just simplifies to a 1. If the exponent is not a multiple of 4, how I can figure out what I'm looking at is to divide the exponent by 4 and look at the remainder. And the remainder will then tell me what power of I need to simplify using these first 4 powers of I. So let's take a look at an example about using the remainders to figure out what power of I I'm looking at. The first practice question is I to the 27th power. What does that simplify to? And your answers, by the way, are either going to be I, -1, -I, or 1. Those are the only possible answers we're going to have to these questions. And how I know which one to respond to is whether or not this thing is equivalent to I to the 1st power, I squared, I cubed, or I to the 4th power. Well, let's find out. 27 divided by 4. Well, 4 goes into 27 6 times. That gives me 24. 27 minus 24 is 3. Okay, so this is telling me that I to the 27th power is equal to I cubed. I want to look at that remainder. And the reason why, just kind of break this one down a little bit more, is I to the 27th power can be thought about as I to the 24th power times I cubed. All right, and the reason why we broke it down like that is because 24 is a multiple of 4. And every time that the exponent is a multiple of 4, that piece breaks down to a 1. You got it. So that piece kind of goes away, and all I'm considering looking at is the I cubed. And so we just need to know what I cubed is. So I cubed simplifies to -I. So that's how that one simplifies. Try the I to the 50th power on your own in a moment, and let's see which one you get it simplified to. So I pause this and take a moment to work through the I to the 50th power. All right, so hopefully you tried that one on your own. Let's go ahead and figure out what's going on here. So I'm going to take that exponent and divide it by 4. So 4 goes into 5 once, with 1 left over. We're going to bring down the 0. 4 goes into 10 2 times, with 2 left over. I want the leftover, I want that remainder, because that will tell me what power is left over after I pull out the multiple of 4. So I to the 50th power is equal to I squared, and I squared simplifies to -1. All right, very cool. Now the last example is I to the negative 21st power. Now if you have a negative exponent, you can't do the division because your remainders are not going to work out the way we would expect them to. So the easiest way to do these ones is to make your negative exponent positive by taking your base and flipping it over the fraction bar, and when you do that you get to change the sign of the attached exponent. Now that your exponent is positive, now you can do your division. So 4 goes into 21 5 times with 1 left over. The leftover is the exponent I want on my I. So I to the 21st power is equal to 1 over I to the first power. We can't leave our final answer like that because we don't leave the imaginary unit in the denominator of the fraction. So we need to get that out by multiplying it by something. Now you could use the complex conjugate in this case, which technically is a negative I. But the other thing is, remember that if you can build an I squared simplifies to -1. So, and this only works if you don't have a real part, if you only have this like pure imaginary part. To get the I out of the denominator, we can just multiply both the top and the bottom by another I. And the reason why that's going to work out for us is, well, let's clean up the upstairs for a moment. 1 times I is just I. But downstairs we are going to get I times I, which is I squared. But I squared simplifies to a -1. So to clean this up, you have a positive divided by a negative, which is negative, and then I divided by 1 is I. So I to the negative 21st power simplifies to -I.